All right, welcome back to homework review for homework number 4. In this assignment, we're going to be tackling if-else statements. Not a lot of changes here other than we're adding this new feature, this new tool called else, which basically means if the condition is not met, we're going to do something else that requires no condition. It's the alternative in all cases. If we didn't want to do the first thing, we're going to do this instead. We're also going to talk a little bit about none in this assignment. Which is the absence of anything. So let's go ahead and get started with if-else statements. All right, for my first problem here, it's telling me write an if-else statement that assigns true to sprinkles if sweet tooth is true, otherwise set sprinkles to false. You should experiment by changing sweet tooth to true and false values, running the code, and then typing sprinkles into the shell or use print statements. So very similar to our prior homework. Let's go ahead and get started with this one. So we want to say, if sweet tooth is true, what are we going to do? We're going to add sprinkles. So we'll say if sweet tooth equals true, then sprinkles will be set to true. Otherwise, sprinkles will remain false. Okay. Now, this line isn't totally necessary, but for the purposes of our homework, we're going to just do what it tells us to do here. So that's just to get practice. All right. We'll run our code. We'll type in sprinkles. And we'll see that because we have sweet tooth set to true, it's going to give us true. But if we set sweet tooth to false, then we will see that sprinkles will also be false. Okay? Now, if you recall from the last assignment I showed you where you could say, if we have a variable that's assigned a data type, a Boolean data type, true or false, right? All we've got to do is say sweet tooth, because sweet tooth represents true in this case, or false, whichever it's going to be. So we can still run this code and still get the same kind of output just from saying if sweet tooth. So I'm going to continue to use that because it's good practice as we go through our assignment. All right. For this one, we're going to write an if-else statement that assigns true to freezing if temp is less than or equal to 32. Less than or equal to 32. Otherwise, freezing will remain false, or we're going to set freezing to false. So if temp is less than or equal to 32, then freezing will remain false. Or true, excuse me. Freezing switches to true because it's freezing outside if it's less than or equal to 32. Otherwise, freezing will be false. Pretty straightforward, okay? So we'll check temp. Temp in this case is 32. Freezing is true. All right. Write an if-else statement that assigns true to can drive if age is greater than or equal to 16. So if age is greater than or equal to 16, can drive will be true. And now this right here is set to none. And I introduced this here, right, because sometimes in programming we want to have a variable set aside for something, but we don't know what it is we're going to put in there yet in all cases. Or maybe we don't want to put anything in there yet for some reason, right? And a lot of times we'll use none as kind of a placeholder for whatever is going to be put in there later. And in this case, we want to do true or false. So we'll check our code out here. How old are we? Age is 15. And we're going to say can drive should be, can drive, not can drive. It's kind of, that's the Australian way, can drive. Can drive is false. All right. So if we adjust age, if we change it to 17, can drive will become true. Easy peasy. Moving on. Write an if-else statement that assigns true to can see if lights is equal to true. Otherwise, set can see to false. So if lights can see is true. Otherwise, can see is false. Notice again, I'm using this shorthand. I'm not saying if lights equals true. I'm just saying if lights because ultimately it represents true or false in this situation. So can see. True, set it to false. You get the picture. And see. For 5 and 5a, we're looking at a pretty straightforward one here. It says write an if-else statement that assigns can go to true if stoplight is not equal to red, okay? So if stoplight is not equal to red, can go is true. But that's not always the case, right? A stoplight can also be yellow. So let's take a look at this little, a slightly more complex batch code here. It says uncomment So if we just highlight all of our code and then you press Control /, you can actually unhighlight, or excuse me, uncomment lots of stuff. Sometimes Replit will be a little weird about it. So what we've got here is a better stoplight, which is yellow. So we say if better stoplight is red or better stoplight is yellow, we probably should stop. Otherwise we can go. And this is using what's called a logical operator. And there are 3 logical operators, which are and, or, and not. And we get into those in the next assignment. But for right now, if we run this, it says I should stop because the light is yellow. If we switch it to red, we're going to get the same thing. But if we switch to green, we say I can go. Okay, last one. We're going to use multiple if statements here. Write a series of if statements with multiple ifs to create a pizza order. If the variable for the topping is true, write a print statement that says adding topping, where topping is the appropriate pizza topping. No else here, so no else keyword at all. All right, here we go. So if pepperoni, print adding pepperoni. You might remember we did this one in lecture to demonstrate the nature of if, elif, and else. So if peppers, print adding peppers. And I can just copy and paste this. Copy, oops. Copy. And I can change my variables, sausage, if tomatoes, and then grab this, boom, easy peasy. Control C, Control V for the win. All right, now if we run this, we'll get adding pepperoni, adding sausage, adding tomatoes, and that's because everything else is set to true except for peppers. And of course, we could experiment with this a little further. All right, that's homework 4.3. See you for the next one.